Hi, this is Mrs. Burlinghoff again, and here we are now for the second part of Chapter 11, Section 4 in Geometry. It's kind of a long section, so I didn't want to just keep videoing and keep talking and being totally boring, so I broke it up into two parts. We're now on our fourth objective, which is to find the area of a regular quadrilateral, also known as a square, using a different method. Of course, everybody knows that to find the area of a square, you can just simply square the side if you know the side length. Side squared equals the area, okay? But what if you're given the radius, such as in this picture here? Once again, you can inscribe any regular polygon into a circle, and its vertices, if you draw a line from the center of the circle to the vertex of the polygon, you'll notice that it's also the radius of the circle. And it's also called a radius of the polygon. Only regular polygons can have radii. Alright, so suppose instead of being given a side length, you're given a radius. And there's a number of ways we can find the area of this square. But one way is to remember some things we've already learned. Do you remember that a square is a rhombus? Because a rhombus is a quadrilateral with four congruent sides. And the area formula for a rhombus we've already been given. So the diagonals of the square are also the diameter. So let's look at this guy. If I extend this radius here to the other vertex, I've actually created a diagonal for this square. Because remember, when you connect opposite vertices, it's called a diagonal. And isn't this piece also 3.6 here? Because it's a radius just like the one above it? Yes, it is. And this other diagonal, if I were to draw it, would be equal to the first one. So that means that I've got two diagonals that each measure 7.2 centimeters, because 3.6 times 2 is 7.2. So I can just plug it into the area formula for a rhombus. And I get 7.2 centimeters times 7.2 centimeters divided by 2. And there's our answer. There's other ways you can do this too. We've talked about it in class. See what you can figure out. See if you're right by trying. For example, you'll notice that when you draw the two diagonals in, the diagonals of a rhombus are perpendicular to each other. So you've got four right triangles inside there. Do you know how to find the area of a triangle? Well, if you can find the area of one individual triangle there and multiply it by 4, I guarantee you, you'll get the same answer. All right, moving on to our last objective. There is a formula that can be applied to all regular polygons, and sometimes it's handy to use. So our fifth objective is to use this formula, A times P over 2, to find the area of a regular polygon. We're going to have to define a few things here. A stands for something called an apothem, which is the distance from the center of a regular polygon to its side. Not the distance from the center to a vertex, that's a radius. But the apothem is the distance from the center of the regular polygon to its side. Here's an example. Okay? Here's the center of the regular triangle. The distance from the center to its side is called the apothem. And then P just stands for the perimeter. So if we're going to use this formula, we're going to plug and chug here, okay? So let's suppose that we have a regular pentagon. Its side lengths are 11.8 inches, and its apothem is 8.1 inches. What are we going to do? Well, first we're going to have to find the perimeter. Since a pentagon has 5 sides, and this is a regular one, we'll just multiply the side by 5. And get 59 inches. Now we're ready to plug it into the formula. The apothem, 8.1 inches, times the perimeter, 59 inches, divided by 2. And our answer comes out to be 238.95 inches squared. And that's the end of the second part of Chapter 11, Section 4, Areas of Regular Polygons.